Okay, welcome back. So in this video, we're going to be talking about estimation and confidence intervals. First, we're starting out with a broad conceptual overview. Um, Nothing too technical in this video. So let's move forward. So if I asked you to estimate the length of this line, you could probably do that. Um, but really, this is kind of a pointless question in some ways because the length or your estimation completely depends upon the size of the screen that you're looking at, right? And if you have the video small or large, so on and so forth, right? So the point is that I don't want you to actually estimate it. I just want you to think about what it means when we are estimating things, right? We're just essentially guessing or giving our best guess. I keep wanting to say estimate, but our guess or speculation or conjecture of some sort of value. And so in statistics, this is essentially what we're doing here as well. Estimation is broadly a procedure in which we're going to take a statistic from a sample. So typically that's going to be a sample mean in these examples. We'll take that sample statistic and use it to estimate some sort of unknown population parameter or statistic, right? So the most basic example, again, being taking a sample mean and using that to estimate a population mean. And we haven't talked about hypothesis testing yet in this course. And hypotheses are something that I think most students are exposed to in some sort of science class or other class earlier in schooling than undergraduate. So if this is new to you or if you need a refresher, don't worry, we'll get to that in upcoming modules. But I would like to at least kind of mention this from the get-go. And that when we do estimation and later in this course when we're doing hypothesis testing, we generally have similar goals, right? We're trying to learn more about some sort of population parameters or statistics, typically some sort of population mean, right? So we do have some similar goals, but they are different, right? These are different processes. So specifically in estimation, we're not making decisions, right? We're just estimating things. When we get to hypothesis testing, we'll see how we're making decisions about rejecting or retaining null hypotheses, right? All this technical stuff. We'll get to that, but at this point, we're broadly just estimating things, right? We don't need to make hard decisions about our hypotheses or predictions. And so here again, we're estimating population means or potentially mean differences, but that's something we'll get to in upcoming modules. And beyond the mean, we'll also estimate the intervals in which it is likely to be contained, right? So kind of a broad guess of within which values or range that population mean is likely to occur. And so those are two different estimates that together, I guess, create like a bigger picture or the full story of our estimation. And so specifically, the estimate of the population mean is what we call a point estimate, right? We're estimating a specific value, a specific point. And then the interval in which it is likely to be contained, that's an interval estimate. And so to give you a visual example here, so if this is a distribution, right, with some population mean, then this right here, this blue dot represents a point estimate, right? It's some sort of value that we're estimating, that we're using to estimate the population mean, right? And then this visual, it falls right under it, so it might not seem like an estimate. I'll show a visualization in a sec that depicts this a little bit better, or a little bit more interactive. And then an interval estimate here is essentially these red dots. It's saying, okay, the population mean probably falls somewhere between these two, right? This would be a minimum, this would be a maximum, right? And so point estimate is specific, interval estimate is more broad. And so let me pull up this visualization here. So this is from the Seeing Theory website. I won't spend too terribly long on this at first. We'll come back to this later in this video, I believe. But so here we have, we're estimating confidence intervals or simulated confidence intervals. We're going to sample from a normal distribution, right? We're going to keep it simple. Choose the sample size and confidence level. For now, let's keep it pretty straightforward. So let's say we want to sample from a sample of 30 individuals and we want 95% confidence. And again, we can come back to this. I just want to show you some examples of point and interval estimates for now. So if we start sampling, Okay, then we can see these samples dropping down from the population. And then with those, essentially, we're creating a estimate of the population mean. And that estimate specifically is the sample mean, right? So just like in previous visualizations, these dots that are coming down from these samples are the sample means, right? And anytime we calculate a sample mean, we're essentially giving some sort of estimate of the population mean, right? Because we assume samples generally represent the population. And you can see, based off our data here, that they generally do, right? If you recall the central limit theorem from last module, we talked about how, on average, sample means approximate to the population mean, right? That was the whole thing we talked about, the central limit theorem and sampling distributions. And so you can see here that that's the case, right? These sample means and then these intervals, right? Here, these intervals are 95% confidence intervals. And you can see the further we're going, the more we are finding sample means or point estimates and confidence intervals that contain the population mean, right? So in more basic sense, does the line that surrounds these dots, these sample means, does that line cross this axis, right, the population mean? And you can see that for most of them, they do, these teal ones, or blue, whatever they look like. The red ones, oh, it's too far out, right? And so again, we'll come back to that. But just wanted to show you an example of what we mean to get things started. Okay. And so we could outline these differences between point estimation and interval estimation. I'll give you this table. I have another table I'm about to show you that I think summarizes it in a little bit more plain terms. But some terms I want to introduce for now on this slide. First, the confidence interval. So this, I think I've already used this term a bunch, but a confidence interval is some interval or range of possible values within which that unknown population parameter is likely to be contained. So in other words, on that previous visualization slide, it was the line, right? It's that range of possible values that probably contain that population parameter. Again, in this case, typically the population mean. And then level of confidence is essentially the probability or likelihood of that estimation. All right, so in that example, I said we were looking at a 95% confidence interval, so we could say we were 95% confident. Or in other words, on average, 95% of the time, the estimation will contain the population mean. Or in other words, if we collect 100 samples, 95% of those samples will contain means that fall within the confidence intervals of the population mean. Or no, let me send that backwards. 95% of those samples will contain means that are estimates of the population mean within that range of confidence. I'm probably doing a poor job of explaining that. So let's just keep moving forward. Some of these things get hard to define the more I talk about them and think about them. So to further compare these, comparing point and interval estimation, what are we estimating and how? In point estimation, we're estimating the population mean, and then essentially we're using the sample mean to estimate that. Is it precise? Very precise, but is it accurate? Maybe we don't know for sure, right? Anytime we're estimating a population mean using a sample mean, or in other words, anytime we calculate a sample mean, we don't know with 100% certainty if they approximate to or estimate the population mean accurately. And so an interval estimation, then, that's kind of our saving grace. We're saying, okay, we can do point estimation and say here's our sample mean, but by using confidence intervals, we can essentially provide ourselves a broader window or sort of a broader forgiveness or level of forgiveness for our estimation there. And so this is not precise, right? Not very precise, but it is fairly accurate. Like I said, we can say specify how confident we want to be with our estimation. So for example, 95% confident. Right, or in other words, yeah, so going back to the previous slide, my botched execution here. So essentially what we're saying is that if we collected 100 samples and we were estimating the population mean or the confidence intervals within which the population mean is likely to be contained, we would be accurate or correct 95% of the time. There you go. That's my better way of explaining that. Okay, moving forward. So to talk a little bit more about precision and certainty, what we mean by this. So the precision of an estimate is determined by the range of the confidence interval. So in basic terms, the smaller the range, the more precise the estimate. So for example, if I'm practicing archery or something like that, and I'm trying to shoot this target, and I want to hit dead center, that's a really small range. Therefore, I need to be very, very precise with my shooting. All right, if I wanted to hit it right there in dead center, you have to be pretty darn precise, right? You probably have to practice a lot or just be lucky as all hell. And then if I asked you to do it again, you probably wouldn't be able to, right? So in the aggregate, you have to be very, very precise, very, very good at what you're doing in order to hit that center consistently, right? In order to be that precise consistently across that small range. And so using this GIF here as an example, excuse me, it's like getting a hole in one. There it goes. And what a shot, right? Amazing. Probably something he couldn't do every single time, right? If he continued playing the hole and trying to shoot from the, oh gosh, what do you call that? The place where you drive from? I can't remember. It has been so long since I've played golf. It's been like probably over a decade. Anyway, point is, he can't do this every single time, right? Golfers, even the best golfers, can't hit hole in ones consistently, right? Because it's such a precise thing to do. And so the certainty then is determined by the level of confidence, right? So in other words, the larger the level of confidence, the more certain the estimate, right? So again, if we are practicing archery and we're shooting at this, if I want to say with 95% confidence that I will hit a particular range of this target, then it'd probably need to be a pretty big range, right? In other words, I wouldn't be very confident about hitting a perfect bullseye, right, to our previous point. But I would be pretty confident about hitting anywhere on the target, right? I think I could probably hit anywhere on the target, right? And essentially, the broader that range is, the more confident I am, right? So if you ask me to hit within the yellow, I might say, okay, I don't know, 10% confident. Within the red or yellow, maybe 20%, right? So on and so forth, right? Until it's the whole target, I'd probably say, okay, 90% confident that I'll hit it, right? And so that's kind of the relationship there between certainty and the level of confidence. And so using golf as an example again, as we increase that the size of the hole here, it's fair to say that our confidence and therefore our certainty is going to increase as well, right? So this person here might say, okay, yeah, I'm fairly confident, fairly certain that I'm going to hit this. This person, I would say, is probably even more certain. This is golf that I can play, right? This is my kind of game of golf right here. Anyway, so hopefully you see my point there. Pretty simple, but something I wanted to outline nonetheless. And so some basic rules of thumb here to kind of summarize this. First, decrease in level of confidence increases precision. Second, increasing the level of confidence increases the certainty. And so in other words, to combine those two, to be more certain that an interval contains a population parameter, we have to give it precision, right? So in other words, if we want to increase our certainty, we have to be less precise. And so in more practical terms, the wider our confidence intervals, right, or I guess let's say the more certain our confidence intervals, the broader that range must be, right? So you can see here, for example, 80% confidence interval is smaller than a 95% confidence interval, right? That extra 15% of confidence is going to naturally increase the range that we are considering for our population parameter. Okay, and that's all for this video. We'll pick up with a little bit more technical information in our next one. We'll see you there.